I welcome everyone to this class. My name is Emmanuel. I am your chemistry teacher on this channel. In today's lesson, we are going to start a new topic, which is about periodic table. In this first lesson, we are going to be exploring a little bit about arrangement of elements in the periodic table. Before we begin, there are a few things I want you to do for me. First, get your study book and pen by your side. Also, ensure you are in a quiet place. Great to start off today's lesson. Please write down today's date and title, which is periodic table. Ensure you have these materials on the screen: a pencil, a book, a pen, cardboard paper, and a periodic table. Please pause this lesson and get them ready. You can get a periodic table from any chemistry textbook or download a copy from any online source. Great, we are ready. By the end of today's lesson, students should be able to state periodic law, define the terms periodicity and periodic property of elements, give examples of periodic properties, identify groups and periods in the periodic table, place first 20 elements in the periodic table. In the reaction mixture on the screen, we have added magnesium ribbon into an acidic solution. You can see bubbles of gas rising to the surface. That gas is hydrogen gas. In another reaction, where we want to produce hydrogen gas without using magnesium ribbon, the question is, which other elements can be used in place of magnesium? Now, we have to use the periodic table for a guide. The periodic table organizes the elements according to similar properties. So you can tell the properties of an element just by looking at its position in the periodic table. Therefore, by understanding the periodic table, you can easily pick another suitable element for the said reaction. Now, let's take a look at the periodic table. This is how the periodic table looks like. What is a periodic table? It's a table showing the arrangement of elements in order of increasing atomic number. In the periodic table, elements are arranged from the lowest atomic number to the highest, and from left to right. Hydrogen with atomic number 1 comes first, followed by helium, lithium, and so on. Can you complete this table? Yes, you can. Periodic law. Remember earlier we talked about producing hydrogen gas without using magnesium ribbon again. So I have to pick an element close to magnesium. The question is, why should I pick an element around magnesium? Example, sodium, potassium, calcium. Why can't I pick an element far from where magnesium is in the periodic table? Example, chlorine. The answer is simple. The idea of choosing another element around magnesium for the said reaction is guided by periodic law. Now, what does periodic law say? It states that the properties of the elements are a periodic function of the atomic numbers. It explains that the properties of the elements are as a result of the atomic structure and vary with the atomic number. So as the elements are arranged in order of increasing atomic number, there is recurrence of similar atomic structure and recurrence of elements with same number of electrons in their outermost shell, therefore falling into the same group. Can you see that? Look at magnesium and calcium. Both have 2 electrons each in their outermost shell. Periodicity. As elements are arranged in order of their increasing atomic numbers, and as you meet new elements with similar atomic structures, the property exhibited by former will be exhibited by current. This is known as periodicity. It is with this fact that elements of similar properties are on the same group. What is periodicity? This is the recurrent trend in the properties of elements with increasing atomic number. What is a periodic property? It is the property of the element that changes regularly with increasing atomic number. For example, sodium with electronic configuration 281 and potassium with electronic configuration 2881 show similar properties, but the atomic numbers are far from each other. They show similar properties because they have the same number of electrons in their outermost shell. This property exhibited by sodium and seen in potassium after some time is said to be showing periodicity and is called a periodic property. Examples of periodic properties include atomic radius and ionic radius, ionization energy, electron affinity, electronegativity and electropositivity, metallic character and non-metallic character, melting and boiling points. Groups and periods. Groups and periods. It is not enough to say pick an element and run magnesium. You need to know the location of these elements in the periodic table by learning about the basic features such as groups, periods, and blocks of elements. The elements in the periodic table are arranged in groups and periods. Groups. These are the vertical arrangements of elements in the periodic table. There are 8 main groups of elements ranging from 0 to 7 or I to VIII. That is 1 to 8 in Roman numeral. If you look at your copy of the table, you will see 18 columns. The first 2 and the last 6 are the 8 main groups. We shall look at the middle 10 columns later. Our focus now is on the 8 main groups. At this point, I want you to pause this lesson and make a table on a cardboard paper as seen on the screen. Another fact to know about group of elements is that the elements in the same group have the same valence electrons. For example, group 3 elements have 3 valence electrons. The valence electron determines the group to which the element is in the periodic table. What is a valence electron? It is the number of electrons in the outermost shell of an atom. Look at the structure on the screen. You can see that the valence electron there is 1. Examples: carbon with atomic number 6, electronic configuration 2,4. Electrons in the outermost shell equals to 4. Therefore, carbon belongs to group 4. Sodium, atomic number 11, electronic configuration 281. Electron in the outermost shell equals to 1. Sodium belongs to group 1. Periods. These are the horizontal arrangements of elements in the periodic table. There are 7 periods ranging from 1 to 7. If you look at your copy, you will see 7 rows as seen on the screen. Are there 7 rows? Check. If yes, it means you have 7 periods and your table is correct. Elements in the same period have the same number of electron shells. Here is a quick reminder about shells and energy level. K shell has energy level 1, L shell 2, M shell 3, N shell 4. Can you remember? Right. We can continue. The energy level N shows the period the element belongs. For period 1, N equals to 1. It means electrons are on the K shell only. Period 2, N equal to 2. It means electrons are on the K and L shell only. Examples: carbon atomic number 6, electron configuration 2,4. Number of shells used 2, K and L. Carbon belongs to period 2. Chlorine atomic number 17, electron configuration 287. Number of shells used equal to 3, K, L and M. Chlorine belongs to period 3. Let's look at the quiz. What group and period is potassium in the periodic table? Atomic number equal to 19. Answer. Looking at the electronic configuration 2881. Potassium belongs to group 1 and period 4. 2. Which element is in group 2 and period 4? Answer. Calcium. Look at the practice questions given. Activity: create element cards for first 20 elements as seen on the screen. Make an empty table as seen below. Reshuffle the cards and open it one after the other. Place each card as you open it on their right position in the periodic table. Send your feedbacks via WhatsApp or email. I look forward to seeing you next class. Always stay safe.